Alright, welcome back everybody. In this video we're going to look at examples 4 and 5 from the extreme values of functions lesson. We'll start with example 4. Suppose that the population in thousands of a certain kind of insect after t months is given by the following formula. P of t equals 3t plus sine of 4t plus 100. Determine the minimum and maximum population in the first 4 months. Now when we say minimum and maximum here, we're talking about the global minimum and global maximum of the population in those first 4 months. Notice that we have our endpoints for this function because it's defined as in the first 4 months. Our endpoints are 0 and 4. So those are going to be two candidates for where the minimum or maximum population could occur. And so we're now going to find our critical points. So we're going to take the derivative of our function. The derivative of p of t is 3 plus 4 cosine of 4t. And we want to figure out when that's equal to 0. I'm going to go ahead and solve this equation using my calculator. So I'm going to type 3 plus 4 cosine of 4t into my calculator. And I'm going to set up my window so that it runs from 0 to 4 because those are the only places that I'm concerned with, are the values in between 0 and 4. So we graph this, and we're looking for the zeros. Oh my, we have several of them. So I need to figure out what all of them are. And I'll start with the first one over here on the left. And that's 0.6047. Okay, that's one critical point. And then the next one I don't recognize off the top of my head as a particular fraction of pi. Normally I'm pretty good with that. But and then I've got 0.9661. And wish I could scroll a little faster on my calculator here, but I'm limited. And 2.1755. And 2.5369. Come on, just write a 6 there. You know you want to. Maybe it won't. Try again. Found a dead spot on my screen. 0.5369. And one more. And that one's going to be at 3.7463. Okay, and so now I'm going to make my table for time and population. We've got all these time values. We've got 0 and 0.6047 and 0.9661 2.661 and 2.1755 and 2.5369, 3.7463, and 4. Alright, now I'm going to evaluate the original function at all of these time values. And so I'm going to go back and utilize my table function like we did in the last video. I'm going to go ahead and type in my function. I missed the one. Okay, and I still have my table set to ask, so I'm going to go ahead and just type in the value 0.60447.9661, 2.1755, 2.5369, 3.7463, here's 3, and 4. Alright, so I'm not even going to fill in the table here. We can just look at it on our calculator screen. I normally would do that, but I'm just going to try and save myself a second here. And so our minimum value that we see in the table here is 100. And our maximum value is 111.9. And so our min is going to be 100,000 of those insects at time 0. And our max is going to be 111,900 at time 3.7463. Alright, that's the end of that example. Let's go on to example 5. We're supposed to determine the absolute extreme value for the function on the given interval. And you've got a pretty complicated function here, q of x. So we'll go ahead and take the derivative of that. So you've got 3x times the derivative of the other portion. Plus the other portion times the derivative of 3x. And we want to figure out where this is 0 or undefined. I can factor an x plus 4 to the negative 1/3 out of this, and also 3. And that gives me 2/3 plus x plus 4. Is that right? 3 and 2/3 x plus, yep, x plus 4. Alright, and so now I can solve this, set it equal to 0. And if I solve this for 0, I find out that it is 0 when 5/3 x plus 4 is equal to 0, which happens at negative 12/5. Yes. So x equals negative 12/5 or negative 2.4 at 0. And the other thing we need to consider here is when it's undefined, and q prime is undefined at x equals negative 4. And so those are going to be values where we consider for the absolute extrema. I'm going to look at my critical points and my endpoints. So I've got negative 5, negative 4, negative 2.4, and negative 1. And I'll go back and substitute those into my original function. So take the original function, 3x times quantity x plus 4 raised to the 2/3 power right? And my table is still set to ask, so I'm going to go ahead and just go type those values in. -5. Come on, negative sign. -5. -4. -2.4. I'm having a lot of calculator issues. And -1. And so I got -15, 0, -9.49, and -6.24. And so my absolute extrema, I have an absolute max of -15. At x equals -5. Pardon me, an absolute min of -15. And I have an absolute max of 0 at x equals -4. And those are the absolute extrema on that particular function interval. Alright, that's the end of this lesson. See you guys next time. Have a great rest of your day.